So we've covered simplifying complex numbers and different powers of I. Now let's talk a little bit about some algebra relating complex numbers, starting with equality of complex numbers. Two complex numbers, a plus bi and c plus di, written in standard form, are equal to each other. A plus bi is equal to c plus di if and only if a equals c and b is equal to d. In other words, this means that the real parts of our complex numbers must be equal to each other, and the imaginary parts of our complex numbers must also be equal to each other. For example, find real numbers a and b such that the equation is true. A plus bi is equal to 13 minus 4i. Let's take a look at the right-hand side of the equation. Notice that the real component of this complex number is positive 13. That would mean that the real component of the complex number on the left-hand side would also have to be positive 13. Notice that a corresponds to the real component of the left-hand side. Therefore, a must be equal to 13. The real parts must be equal. Similarly, the imaginary parts of the complex numbers must also be equal to each other. On the right-hand side of the equation, I have negative 4i as the imaginary part. That means I have to have a negative 4i on the left-hand side of the equation as well. Well, if I'm going to have a negative 4i, that means b, this constant multiple in front of my I, must be equal to negative 4. Let's try one that's a little bit more challenging here. A plus 2 plus the quantity 2b minus 3 times I is equal to 4 plus 7i. Notice that on the right-hand side of the equation, the real component of the complex number is 4. A plus 2 is going to make up the real component of the left-hand side. This means that the quantity a plus 2 has to equal 4. We can set up that equation and now solve for a by subtracting 2 from both sides of the equation, giving us a is equal to 2. For our imaginary parts, on the right-hand side of the equation, I have a 7i. Well, 2b minus 3 is the constant multiple in front of the I on the left-hand side of the equation. In order for this equation to be equal, 2b minus 3 has to equal 7. Those constant multiples must be equal to each other. So we can set that equation up. 2b minus 3 is equal to 7, and solve for b by first adding 3 to both sides of the equation, and then dividing by 2, giving us b is equal to 5. There we have the equality of complex numbers. Let's now talk a little bit about addition and subtraction of complex numbers. If a plus bi and c plus di are two complex numbers written in standard form, their sum and difference are defined as follows. The sum a plus bi plus c plus di is equal to a plus c plus the quantity b plus d times I, and a plus bi minus c plus di is equal to a minus c plus b minus d times I. Now, this all looks very, 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 very confusing. Don't worry about these formulas. There is no need to write them down at all. All you need to do is combine your like terms. In other words, combine the real parts and combine the imaginary parts of your complex number. 13 minus 2i plus negative 5 plus 6i. Well, let's combine our real parts. I have a 13 plus a negative 5. 13 plus negative 5 is 13 minus 5, which gives us a positive 8 for our real component. And I have a minus 2i plus 6i. Negative 2 plus 6 gives me a positive 4, giving me 8 plus 4i for my final answer. Again, don't overcomplicate it. No need to memorize these fancy formulas or equations. Just combine like terms. Let's try another one here with some subtraction. 3 plus 2i minus the quantity 6 minus 8i. One thing to be careful of is that we need to distribute negatives here. All right? We are subtracting this entire complex number, so be cautious of that. I have 3 minus 6. Again, combine the real parts. 3 minus 6 gives me a negative 3. And I have a 2i minus a negative 8i. Subtracting a negative turns into addition. 2i plus 8i gives me 10i, and I have negative 3 plus 10i for my final answer. Notice that whenever we're writing a complex number in standard form, the real part always comes in front of the imaginary part. Real component plus the imaginary component. All right, let's try one more here. 8 plus the square root of negative 18 minus 4 plus 5 root 2i. Well, the first step, again, whenever you guys see negatives inside of square roots, remember that you can get rid of that negative in the square root by replacing it with an I on the outside. That would leave me with 8 plus root 18i. That's the same thing as the square root of negative 18. Well, are there any factors of 18 that are perfect squares? 18 is the same thing as 2 times 9. So this radical, root 18, actually reduces into 3 root 2. So this is 8 plus 3 root 2i minus 4 plus 5 root 2i. Now that we have simplified the radical, the square root here, we can now combine like terms. 4 minus 4, my real component. Combining those gives me a positive 4, and I have 3 root 2i minus 5 root 2i. Well, if I have 3 of anything and I subtract 5 of anything, that gives me negative 2 of that anything. In this case, a negative 2 root 2i. So my final answer, 4 minus 2 root 2i. All right, there we have equality of complex numbers and some basic addition and subtraction of complex numbers.